Welcome to Module 2. In this module, we're going to be talking about descriptive statistics. So we've talked about the two major branches of statistics, descriptive and inferential, but in this module, we're really going to start to study those descriptive statistics, which consists of methods for organizing and summarizing information. So we'll start by talking about some definitions. A characteristic that varies from one person or thing to another is called a variable. And so there are a lot of examples of variables for humans or anything that we can see all over the world. An example for a human would be like our height or our weight. Now, we can have variables that give us numerical information, and these are called quantitative variables. And then we have variables that do not give us quantitative data. They are called non-numerical qualitative variables. And we can break this down even further, starting with our numerically valued variables or our quantitative variables. As you see, they can be further broken down into either discrete or continuous. A discrete variable is something that involves a count of something, whereas something that is continuous usually involves a measurement of something. So in this graphic that I'm showing here, you can see that on the left-hand side, we have continuous variables. These are an interval of numbers that's something that can be measured. And so examples would be like height, weight, or battery life. When you think about continuous variables, keep in mind that these are the types of variables that can have decimal places. And then we have discrete variables. Now, this is a quantitative variable, but the possible values can be listed. So they can be either finite values or countable infinite values. And some examples of this would be your siblings, the number of siblings you have, for example, the type of car or maybe the color of car, and just information about the students themselves, how many there are, for example, and maybe we would classify that further into something like gender. Data are classified according to the type of variable from which they are obtained. And so when we have data, we have a value of a variable, and then we have different types of data, and from there we can create a data set. And here I just wanted to present to you all of the definitions that we talked about. And of course, one of the figures, this is figure 2.1 from the WISE textbook on the types of variables. So you can see that we've got all of the definitions and all of the different types of variables with their further classification. Obviously, there's more than just what we're showing here. There's also ordinal, where it is an ordered set, or you can have a nominal, which would be like a name. And so those are both types of qualitative data variables. So let's look at an example together. Human beings have one of four blood types, and this is not including our Rh negative and positive factors. We're just looking at the basics of our A, B, AB, or O. And so the question here is, what kind of data do you receive when you are told your blood type? Well, blood type is a qualitative variable because its possible values are non-numerical. So your blood type is qualitative data. Example here. So Stats Canada gathers information about how many people live in a home. What type of data is the number of people living in your household? Well, household size is quantitative, but it's also a discrete variable because its possible values are 1, 2, and so on. So therefore, the number of people in your household is quantitative, discrete data. And here's a fun critical thinking question. Is money continuous or is it discrete? So at first glance, you might think, well, it's continuous because you can have decimal places like $10.50. It looks like you can split it into endlessly smaller pieces. But there is sort of a twist. In real life, money is discrete. Why? Because it becomes in fixed units. You can't half a penny. Well, at least not in everyday use. So the smallest unit, like a cent, sets a limit. That means you're always counting steps rather than sliding smoothly along a line like a ruler. So if we think about money in theory, like in mathematical models, it can be treated as continuous. But if we think about money in real life, it's discrete. I know, you're so bored. You're like, why is this important? Why do I have to learn this? The reason why we go through this is because some statistical procedures that you'll study are only valid for certain types of data. This limitation is one reason why you have to be able to classify data. If you don't know what type of data you have, you're not going to use the right statistical test. And so the classifications we have discussed, they'll be useful for us so that we can apply this. Statisticians will have additional classifications, or it can get more complex than this. Data classification in general, it can be very difficult. And even statisticians will disagree sometimes on if something is discrete or continuous, like in money. But in most cases, it's fairly clear, and so we have to choose the correct statistical method for analyzing the right type of data. Okay, so we're going to move into talking about how we can organize qualitative data first, and then we'll talk about organizing quantitative data next on its own. One way of organizing qualitative data is to construct a table that gives the number of times each distinct value occurs. And you probably have done this when you've played games in the past where you're tallying up your score. This is the number of times a particular distinct value occurs, and it's called its frequency or its count. So, a frequency distribution of qualitative data is a listing of the distinct values and their frequency. And what I'm showing here is the procedure to construct a frequency distribution of qualitative data. Your first step will always be to list the distinct values of the observations in the data set in the first column of a table. And so you can see, for example, in table 2.1, there were political party affiliations of the students in an introductory stats class. And they just simply listed if they were Democratic, Republican, or other. And obviously, this is America. Then, for each observation, a tally mark in the second column was put in. And so this would approximate a distinct value. So you can see for the Democrats, there were 13 tally marks, and so the frequency was just 13. Most people are able to just do column 1 and 3. They don't actually have to do the tally part in the middle, but sometimes it helps to get into the practice by tallying it first and then recording the total. And I implore you to pause the video and try to do it for yourself in this example. So we have 20 students and they were asked for their favorite Taylor Swift song. And we were asked to determine the frequency distribution of these data. So simply 20 different students, so at least we know the total should equal 20. And they just listed their favorite Taylor Swift song. And so if we started to tally them and then add the count, this is what we would get in the end. And again, the total should equal 20 because we know 20 students were asked for their favorite Taylor Swift song. So you should definitely go back and try it for yourself. So, in addition to frequency, we often want to know the relative frequency as well. And this is the ratio of the frequency to the total number of observations. And you can see that I've got a formula here. Now, you are going to be given a formula card, but often your formula card won't have everything on it. So, what I recommend you do right now is pull out a fresh piece of paper and start to make your own formula card. And this can be one of the formulas that you put on your formula card. It is the relative frequency, which is equal to the frequency divided by the number of observations. So let's look at the procedure on constructing a relative frequency distribution of qualitative data. So first, you obtain a frequency distribution of the data in the same manner that you had done it before, and then you divide each frequency by the total number of observations. So why would we want to do this? They are better than frequency distributions for comparing two data sets. And that's because relative frequencies will always fall between 0 and 1, and so they provide a standard for comparison. Often what you will see is that we will have a relative frequency distribution, which will fall between 0 and 1, or people will turn it into a percentage by multiplying their final answer by 100. Either one is fine, and they work with each other. And of course, I'm going to show you an example and I'm going to base it on our Taylor Swift information. So we've got all of our different counts in the second column here for the favorite Taylor Swift song, and you can see the grand total is 20, and that matches up with our 20 students. If I want to calculate a relative frequency distribution for each one of these, we'll have to lean back in and remember the equation, which would be the count or the frequency divided by the total. So, for example, August was one person's favorite song. One person out of a total of 20 equals 0.05. Now, Anti-Hero, 4 people said that was their favorite song. So 4 people divided by the grand total of 20, and that is equal to 0.20. And so on from there. I didn't show the work for all of it. But when you add them together, they should add up to 1. Just as if you had made this into a percentage, the percentage would add up to 100. Now let's talk about visuals that will make for qualitative data. And I'm going to walk you guys through the procedure, but we're actually going to do a lot of this in our lab. So keep that in mind. I'm not really going to ask you to hand draw any of this stuff. It's just not something that we do in real life. When we're looking at these visuals for qualitative data, there are a few things that I would like for you to keep in mind. So one of the things is color. When you are printing out a report, or say you're doing something for a class and you want to have a visual in there, some people have different types of color blindness. So I always recommend black and white. It also helps with saving on printer paper and ink as well. And I also recommend always outlining all of your visuals in some sort of a black. So if a person can't see color, at least they can see the outline. And this comes from my time working as the manager of institutional research. I would have to develop a lot of reporting metrics, and we had a colleague who was almost completely blind, and they had a really hard time seeing color. And so that's why it's very important to make things look clear, crisp, and professional. And my recommendation is always black and white. Okay, we're going to talk about my most hated visual, the pie chart. I hate pie charts. They don't have a lot of functionality unless you're talking about literal pie. Most of the time, a pie chart could just be a really nice table. So let me walk you through the procedure, how you make it, and then I'll tell you why I don't like them. So a pie chart is a disc or a circle, and it's divided into these wedge-shaped pieces, and they are proportional to the relative frequency of the qualitative data. So the size of them will be bigger if you've got a higher relative frequency. So to make the pie chart, what you have to do is you have to turn your data into a relative frequency distribution. And then from there, what you'll do is you'll divide the disk into those pieces proportionally. And then you'll label your slices with the values and their relative frequencies. And so the example I'm showing here is the pie chart of the political party affiliation data, and we looked at that relative frequency data before. And so it works okay when you only have three slices. It's pretty clear. You can see the Republicans, Democrats versus the other. So one thing I want you to notice here is that we express the relative frequencies as percentages here. Either method, either leaving it as a decimal or a percentage, is acceptable. Most people will recognize the percentages a lot better. So looking at this here, if somebody had color blindness, they would still be able to tell proportionally how many people were Republican, Democratic, and so on. But what I don't like about pie charts is because of their circular shape, there's a lot of white space around the square where you would copy and paste this in, and it takes up so much more room than it should. And I'm going to give you guys another example of why pie charts just don't work most of the time. In this example, it's fine, but it's very rare that you would find an example like this. And honestly, on a professional sense, if you only had three data points like this, you could just put it in a table or like simply point format. So for all my little Swifties out there, I made a pie chart of the Taylor Swift favorite songs, and you can see how horrible it looks as a pie chart. So there's a couple things. First of all, there's so many different little data points in there that it's really hard to match up the legend to what the actual pie chart is saying. Like there's a couple different oranges, like Anti-Hero and Shake It Off are very similar in color. So you would maybe want to put the actual title of the song on the slice of pie, but there isn't enough room. And then the percentages, there's just too many of them, and they're all so similar that the wedges are all around the same size. There's a couple other things about this that I want to point out, and one of them is the title of it. When you're doing this for lab, or say you are out in the real world and you're doing this, or even for another class, putting the title pie chart of Taylor Swift's favorites is just not enough information. You should be critical. You should look at something like this and think like, what am I missing here? Because you're not getting all of the information. For example, it says pie chart of Taylor Swift's favorites. You don't know how many people this was based on because it's a percentage. So it could be based on like three different people. It's just not a good visual at all. Now, the other type of visual that we can do for this type of data is a bar chart. Now, there are a few things that I'm going to say, and you might want to write this down. Bar charts and histograms are not the same thing. And on Excel, a bar chart is on the horizontal, like it's flipped. And so if you're going to make a bar chart on Excel, it's called a 2D column chart. I know. Don't worry, you'll get into it when we're in lab and you'll understand what I mean by that. So a bar chart displays the distinct values of the qualitative data on a horizontal axis and the relative frequencies or percentages of those values on the vertical axis. So the relative frequency of each value is represented by that bar, that vertical bar, and the height of that bar is equal to the relative frequency of the value. So the bars should be positioned so that they're not touching each other at all. If you do it in a way where you make the bars touch, you're representing more of a histogram, and they're two completely different types of data. So just rule of thumb, bar charts, don't let them touch each other. Again, this bar chart here that we're showing, it's all right. This is something that is a lot more obvious. You would see this a lot more in, say, a journal paper or a lab report, for example. You'll see that it's got a figure title, figure 2.3, and the title from the book is Bar Chart of the Political Party Affiliation. Again, not enough data. You should be very critical when you see things like this and start to ask some questions. So what should a figure title really include? Who, what, when, where, why, and how. And if you don't have that information, then you just don't include it. So for example, this chart title should really be referring to a survey of political party affiliations of students, and then you would say how many there were that were actually surveyed. So maybe it's 20, and then you would say n equals 20, n being the total number or the count. And then you would add why. Why was this done? If you have that information, how, and then how was this created? This chart was created on Excel, for example. So we need to add a lot of context to this information. Now, the other thing I would say about this particular bar chart is that there should be label like percentages above or within each of the bars. And I turned our Taylor Swift songs into a bar chart, and this is the absolute most disgusting, worst looking chart I've ever seen in my life. And I hope that you guys look at it right now and start to wonder, like, okay, what's going on here and maybe why am I saying it's so bad. So I'll give you some context here. There are no axes titles at all. I don't know if I'm looking at a relative frequency, a frequency. I don't even know what August, anti here, all of that along the bottom. I don't even know what that's referring to. And they are obviously songs. They're different songs too. So the fact that they're all one color is kind of wrong, actually. Because they are different, they should almost be different colors. And if you look at the figure title as well, bar chart of Taylor Swift's favorites, well, don't you have so many more questions? Now, I'm not going to lie to you guys. I'm not a huge Swiftie. I don't mind her. But for example, the song Shake It Off, like I know that's a really, really popular song, but I know that people are so intense about Taylor Swift. I can't actually imagine that making this list. Am I right? Am I wrong? I don't know. Email me if you want to. So anyways, remember to be critical of these things. So I'm all fired up about pie charts and bar charts now. So we're going to end it here and then catch up with you on the next video.